Alright, so on the quiz we just did, phosphorus had this orbital notation. Okay? So based on what you know about phosphorus then, we're going to do something called electron dot notation. And electron dot notation, once you learn to do electron configuration, electron configurations and orbital notation, electron dot notation should be like super simple. So we're not going to spend a lot of time on this. Okay? The reason I've been emphasizing over the past several days what the valence level is, okay, is because electron dot notation is all about the valence level. So if I'm doing electron dot notation for a phosphorus atom, I just count the electrons in the valence level. And 3 is the highest energy level for the electrons. Both 3s and 3p are together making up this valence level. 3 tells you the valence level, so the highest energy level is the valence level. So there are 2, 3, 4, 5 electrons in an atom of phosphorus's valence level. Okay? So what we're going to do for an electron dot notation is, I want you to imagine there's a square around this. Okay, imagine it. Don't write it down. Imagine there's a square there. And we're going to put one dot on each of the 4 sides of that square. Alright, now that's 4 of those 5 electrons, and now I need one more electron, so I simply pair up on any one of the 4 sides, and it doesn't matter where. That makes sense? I just happen to put it on the paired on the top, but the pair could be on the bottom. It's perfectly okay to do that, or it could be on any one of the sides. Huh? In physical science, probably. Right. Now, some teachers may not teach that. I don't know. So that's why I'm trying to review it. So it shouldn't be really hard. I mean, you either had it in physical science or it's based on this, and it should be pretty easy. Okay? Now, what would be different is how do we write the orbital notation, the electron dot notation for the phosphide ion. So this is the phosphorus atom. Okay. Then for the phosphide ion, you have to have that charge on there. And how many electrons are in the highest energy level, which is the valence level of the phosphide ion? 8. One dot on each of the 4 sides. And go back and pair them up until you have a total of 8. And so a phosphide ion looks like that. Now wait a minute. Hold on one second, because I want to be clear about something. Sometimes it's really difficult to tell where that 3 negative belongs, okay? And when we get to more complex ions and things, it might be more difficult. So it's better if you take the electron structure and put it in brackets, like this. I'll show you. Put this electron structure in brackets like this and put the 3 negative outside. And that makes it clear that the 3 negative belongs to the whole thing, not just some part of it. Does that make sense? Okay, so we'd prefer not to do it this way. Okay, this is preferred for an ion of phosphide. Got it? So this is the phosphide ion. Alright, so this I hope is easy. Does it seem easy to you? Alright, so let's practice then. If you want to, if you know what that means. Okay, so there's your practice problem. Write the electron dot notation for a chlorine atom and the chloride ion. Alright, so here's our practice problem, and here's the answers that were given by students. So the atom of aluminum had 3 electron dots. If we were doing the orbital notation, the highest energy level would be 3s2 and 3p1. If we did electron configurations, if we did orbital notation, you'd come up with the same thing. That's where you get it from. So we'd have 3 dots in the aluminum's the electron dot notation for the atom, and that's what we have here. So the easiest thing, what you want to do is try to get to the point where you either removed all the electrons or you have 8. So if I put 8 on there, it'd give us an ion that had a 5 negative charge, but that's not what aluminum does. And if you're not sure of that, you can one way to kind of help figure it out, okay, is to look on your periodic table with oxidation numbers. Aluminum only has a 3+ charge available to it. Okay, I don't have any other choices on here. It might be possible to make one of these, but it's really, really hard, and we just don't pretty much do it. Okay, so the aluminum then, if it has 3+ charge, it's going to get that 3+ charge because you remove 3 electrons. The aluminum, the atom, has 13 protons. And so for the atom of aluminum, it's also got to have 13 electrons, so that the protons, which are positive, balance out the electrons that are negative. Okay, you have to have an equal number of protons and electrons, an equal number of positive charges and negative charges for an atom to be neutral, and all atoms are neutral. So if I remove 3 electrons, then I've got 13 protons and 10 electrons. So that's 13 positive charges and 10 negative charges. Add those together, you're going to get a 3 positive charge, and that's where we get the aluminum's 3 positive charge on the symbol here. Does that make sense? So it looks like we might need a little more practice. Maybe a couple more, and we'll move on to the next subject. Okay. Now you can work with a neighbor if you'll do so quietly. Okay, and let's see how you do on these. I'm going to give you 2 more. Okay. All right, you need to be very careful with those symbols, okay? Ca is calcium. All right, so this is the correct electron dot notation for a sulfur atom. This is the correct electron dot notation for a sulfur ion, a sulfide. We call it sulfide when it's a negative monoatomic ion. This is the correct electron dot notation for a calcium atom, and this is the correct electron dot notation for a calcium ion. We don't change the name of it, we just call it a calcium ion. Okay, so we're going to write electron dot notation for, let's see, how about we say for the atom and ions of, you want to do zirconium? How about we do it for one silicon positive ion and 2 silicon negative ion. Okay? How about that?